right, so now what we're looking at is optimizing volume and surface area. Now, when we're talking about optimizing volume and surface area, and first of all, today we're looking at no restrictions. And when we do have restrictions, we're going to do that together in class. What we're looking at is we want to optimize, we want a maximum volume with the minimum amount of surface area. So we want the volume to be as large as possible, but we want to use as the least amount of surface area. Now this has a lot of practical applications when we're talking about especially packaging. So that's one reason why we're studying it. Now, when we're talking about volume, we're going to be talking about a rectangular prism. Okay, now there are other things that we can optimize the volume for, and that includes cylinders, as well as later on you're going to also be doing an assignment where you're working with other shapes, other objects to see what their optimization is. However, you're going to find that for the most time when we talked about optimization, volume and surface area, we want to talk about a rectangular prism because of the packaging. So when we're talking about a rectangular prism, the best shape is a cube. So the cube is the ideal shape. Okay, now when we're talking about a cube, remember all of the dimensions are the same. So in many cases, again, just like when we did the square, we use an S for the side length. Now, if we talk about the surface area, remember there are 6 faces on a rectangular prism, so 6 faces on our cube. And when we have that, what we end up having for our formula is we have 2 faces this way, a top face, a bottom face, and 2 side faces. So we end up with 6s squared. So the area of one face is s times s, is where we get our s squared from, and there are 6 of them. When we're talking about the volume of a cube, we're talking about s times s times s, because it's length times width times height. They're all the same, so we end up with s cubed. So the first example we're going to look at is when the surface area is given to us. So it asks us to construct a regular prism using exactly 294 centimeters of cardboard. It must have the greatest volume possible. And what are the dimensions of this prism and what are its volume? So as soon as I see the word greatest, I know that I'm talking about a cube. Okay, so it's the cube that we're after. So using the information that I have with my formulas, they tell me here what my surface area is. So I'm going to use that information and substitute it into the formula that I talked about a few moments ago. So we're going to take that formula, and that formula is surface area equals, that doesn't look very nice, sorry, surface area equals 6s squared. The surface area has been given to me, and what I can do now is I can actually solve for s. So the first thing we're going to do is divide both sides by 6, and when we do that, we end up with our left side being 49, and that is s squared. So in order to find s, we take the square root of both sides, and the square root of 49 is 7. So we know our side length is 7 centimeters. Then what we need to do is the volume, and they tell us the volume was s cubed. So that would mean that I'm going to take 7. We're going to cube it. We end up with 343 centimeters cubed. So again, a question like this, I probably would put a therefore, and this time I'm going to type it as well, just because it does save time and memory. And up it comes. The cube side length is 7 centimeters and will create a volume of 343 centimeters, and it's going to be cubed. Okay, so let's look at the next example. This time the volume is being given. So we're still using those two formulas from the first page that we looked at. And again, we want the least amount of surface area possible. So again, when I see that, I'm thinking cube. Okay, so it's important for us to remember cube. It's came up quite a bit. So let's start again with our formulas. We know the volume formula was s cubed. The volume's been given, so we put that into our formula. And now we have to take the cubed root. So a number multiplied by itself 3 times to get this number. Now, a lot of scientific calculators will have a few different functions keys for that. Some will have what they call a cubed root button, and it'll look like a square root, but it'll have the number 3. Okay, and I can use that. Or some calculators will have it with the number 1/3. Or if all else fails, what you can do is you can go 4,125 to the power of, and you can go 1 divided by 3, and that will give it to you as well. Now, this isn't a perfect cubed number, so it's not. So I'm going to end up with a decimal of 16.04, and that's going to be feet. And that looked like not very nice. So 16.04, and that's feet. So I know the dimensions in my cube. My cube is going to be 16.04 for all its side lengths. Now the next thing they ask me also is, what is the surface area? So that's the next thing that we have to do. So I'm going to bring this down, and now we're going to calculate the surface area. We know the surface area from the first page that we talked about together equals 6s squared. Again, we know what s is because we calculated it in our previous calculation. We substitute that in, make sure we square it, and we end up with 1,543.69 feet squared, because we're talking about area. Okay, again, do a little therefore, and again, I'm going to type it just because it saves time and memory. Therefore, it is a cube with side length 16.04 feet and surface area of 1,543.69 feet squared. Okay, that's the end of today's lesson.